We have another example on the board. Again, we have two input NOR gate, and we're supposed to determine the output waveform when the switch is open and switch is closed. When switch is open, both inputs are going to receive zeros. Okay, why? Because the first input is connected to the pull down resistor and connected to ground. This is going to bring 0 to this input. And the second input is connected directly to ground, which is going to also give me logic 0 at that input. When both inputs are receiving zeros, output is automatically 1. Okay, so without thinking too long, you can draw logic 1. Okay, and this is the solution for the first part of my problem. When switch is open, output is going to be always 1 according to the truth table. Next, we're supposed to see what will happen if I'm going to close the switch. If I'm going to close switch, I'm going to apply the input signal to the first input. Okay, please notice that we need pull down resistor in order to protect the circuit from short. Okay, so this resistor is just making sure that if you are going to apply the input signal, you are not going to short that signal to ground. So with this resistor, you can safely plug in the input signal to the gate. Okay, so what we have? We're supposed to first draw the dash lines at every single change, every single transition from 0 to 1 or 1 to 0. Next, we have always logic 0 at the second input. Okay, and at the first input we are going to have, let's say at this moment, 0. 0, NOR, because this is NOR function, NOR 0, 0, NOR 0 gives me 1. That's why I'm going to write 1 over here. 1 NOR 0, okay, because at this moment I'm going to have 1 at this input. So if 1 NOR 0 gives me 0. 0 NOR 0 gives me 1 according to the truth table. 1 NOR 0 gives me 0. 0 NOR 0 gives me 1. 1 NOR 0 gives me 0. And 0 NOR 0 gives me 1. Okay, remember we apply these logic levels to the input, okay, and perform the analysis in reference to whatever happens at the second input. That's why I got waveform which looks like this. Okay, please notice that the output waveform is the complement of the input waveform when switch is closed. So these two waveforms are the solutions to my problem.